Remember domain and range a little bit more this time than we do from Algebra 1. So, pick up that calculator. What's the button lets me do cool crap?
Menu.
Menu, okay?
Window.
Well, you're wrong. I want you to click on trace. Okay? So, Brady, where's your calculator? Pick it up. Chris, where's your calculator? You looking on with Chelsea? Okay. So, what I want you to do is I want you to go to graph trace. Okay?
Where?
Okay.
Under trace, go to graph trace.
No, I don't want to.
And you'll notice that it gives us a point. Right here. Hey, Dewan. I need you here. Okay. So, it gives us a point. It tells us what the coordinates of that point are right here. And I want y'all to remember, we said domain is all of my what? X values, okay? So, that means I need to keep going which direction? To the right, okay? So, watch this, and you follow along on your calculator too. Tell me, when does it stop going to the right? It doesn't. Oh. What does that mean about my x if it never quits going to the right? Okay, so it is an infinity, but we need to be careful. That's just talking about to the right. That's only the maximum x. The maximum x is infinity. What about going to the left? Does it ever quit going to the left?
No.
So I'm still following it left, still following it left, still following it. Okay, going left, going left. Does it ever quit going left?
No.
No.
I mean, I'm still going left.
I don't know what you're talking about.
Still going left. Huh?
Can we stop going left?
What? No.
It's never gonna stop me.
Is it ever going to quit going to the left?
No.
No. So what's my minimum x?
No.
Negative infinity. Hey guys. What's going on, guys?
Shoot get your clothes out there.
That's her space. That's her group.
Gee, Willow Christian, everything's a problem here.
So, we have a minimum x and a maximum x. So what is a statement that we can make about what my domain is? Is what? Heard someone say something. Kind of.
All values, x values are both negative, positive, infinite.
Wait, so are the x values just negative infinity?
Negative.
Am I done? Statement? Saying this? Are my x values just negative infinity and just positive
It
infinity?
says x values. X values.
So the minimum's negative infinity, the maximum is positive infinity, and it's everything what?
Infinity.
In between.
Okay.
I need us to pay attention to this, right? The minimum was negative infinity, the maximum was infinity, but we also had all the stuff in between, didn't we?
Yep.
Jaquel, can you take your hood off, please? So we had everything between. So in mathematics, we can make the statement, everything, the domain is everything between negative infinity and positive infinity, right? Or we should really say every x value. Now, in mathematics, we have developed a notation for this. Y'all hopefully talked about it last year called an interval notation.
Nope.
I don't remember that.
Don't remember
I know
that?
what interval
I have
notation
Mr.
is.
Johnson.
I'm glad you do.
You don't.
Okay, so here's the beauty of it. So pause for a second. Watch this. You see where it says minimum?
Yo.
And then you see where it says maximum?
Yo.
And then if I wanted, that's the minimum, that's the maximum, and if I want to tell you that it's everything in between,
Zero.
I just put a comma in between. That simple comma tells a reader that it's everything from negative infinity to positive infinity. That's it. That's interval notation. Now, there is one more thing we add to this. We put parentheses around it. Sometimes we use brackets. Tyler, that's not your group, is it? Dude, you literally sat down behind Deanna. Go back to your group. Man, we can find all the excuses to do the least, but I ain't about that life.
We know.
Yeah. So,
You got that math right.
minimum x to maximum x. So, see, here's the thing. It's not just about that math life. It's about it translating to all our entire life of doing the most and not the least, and actually stepping up and going above and beyond and chasing after excellence in every part of our life. Sometimes that requires doing things we don't want to do. So, minimum x and maximum x. Okay? All that we need to recognize here is that we need the minimum, the maximum, and a comma in between. There are some times that we use a bracket here, a square bracket instead of a parenthesis. I will show you that when we get there, okay? So don't sweat that right now. So what would my range be?
25.
It's all the y values, right?
Yeah.
What do I need first in my interval notation? I need the,
Infinity.
well, not just that, because sometimes, but I need the minimum, right? I need my minimum y value. What is my minimum y value? We kept going down, right?
Infinity.
Close.
Negative infinity.
Was it on
Negative
the
infinity,
thing?
yes.
It was on Matthew, yes.
Yeah.
Uh-huh, yep.
We negative infinity.
Does it ever quit going down?
No.
As we went to the left, it also was going down. And so what was that minimum y value again?
Negative infinity.
Negative infinity.
Yes.
Comma. What's the max or the maximum y value?
Positive infinity.
Positive infinity?
Yeah.
Okay. So, when we talk about identifying all of those x values, all of those y values, what are the two things you need? The minimum and the maximum. And that's it. So, one, I need y'all to write this down on this sheet to first off make that note to yourself about what domain is. When we say domain, what do we say? Or what is domain? All x values. If you hear the word domain, you need to think about what?
All
X
right.
X values and inputs. If you hear range, what do you need to think about?
All
All the y values, also known as the outputs. And then if you're using interval notation, hey guys, right here, Amber. If I'm talking about my interval notation, by the way, that's what this is called. Okay, so interval notation. What always goes first in an interval notation?
No, the crazy.
The minimum, right? And so remember, I will remind you, Juan, because we haven't talked about it yet, there are brackets sometimes.
I know that.
Okay, but we always need a minimum value, and then a comma, and what goes after that minimum value?
The maximum.
The max value. That comma literally just means everything in between. So when you use an interval notation, you put a minimum
And a maximum.
and a maximum, and what goes in between? A comma. Why is there a TI Inspire just sitting here? Brady?
I'm pretty sure it's Brady.
Where did this one come from?
Can you please write that down?
Do we have it written down about the minimum? Well, it's in Matthew. So, you can put it on the back.
Thank you. It's not even no internet camera. You should become a judge. Right.
Why would that be an English teacher? I
Now,
love
if it was
that.
that like much influence the English class, I would love. But because when he talks about stuff, I have he's not a hard teacher. I don't never tutoring.
Hey, go on. Are you distracting Amber so she cannot take these notes?
You tell them the word. You see the homework, tell them the word. What's the homework? Amber, what homework, dude?
Okay.
Who's doing that work? What are you talking about?
Okay.
You gonna have to show me.
Hey, Tosh, you got all your notes down? Okay.
You remember to get on that paper and have like the. Like.
All right. We got to finish this up, and then we'll get some practice with this tomorrow.
Where you going?
Huh?
Are you sure that was last
What
He
you
don't
say?
even know he just.
You want to go where you going? Right down the calculator.
No, you already are here.
I talking about on the calculator.
You're already here.
Okay.
Okay.
Out of the way.
Bud.
Ladies and gentlemen, I need eyes and ears on this. We should be done with our notes on this information if we started taking them when I asked you to. Tosh.
Took my notes.
Hey Tosh,
Hey, Taj.
I need your attention up here. Okay. So, the function through here, is this increasing or decreasing?
That is definitely increasing.
Which one's the one?
It's like a roller coaster.
Oh, when you talking about that one, just that line right there?
Just right here.
Oh, that's increasing.
That's increasing.
Like a roller coaster.
How do I know that it's increasing?
See it going past the x-axis?
Now, I need y'all to remember, when we're talking about that going up, it's much like when we talked about reading a graph before. How do you read graphs? Always from left to right. Okay, I go from left, I go to right, and as I went from the left to the right, it was going up. Here's what I also want you to pay attention to, because it's going to help you, and I need you to make this note. Right here, if I draw a tangent line, you don't have to worry about the tangent word, but tangent just means it's only touching at one point. Is the slope of that line positive or negative? Positive. That's how I know that it's increasing there. I know that it is increasing because the slope of that line is what? Positive. Okay? Now, all of a sudden though, up here, what starts to happen?
Decrease.
It starts to decrease.
Is that a word?
Decrease, yeah?
Decrease.
No, that's not a word. So, it decreases through here. How do I know it's decreasing through here? Okay. One, it's going down. Two, the slope of that tangent line, is it positive or negative? That's negative. So, what am I going to call this up here?
Tangent function.
What's that?
Negative 10. Oh, the
Now, remember, back up. Dog, I just said back up, chill. I need us to remember, line of symmetry, vertex, that was all from a parabola, right? Is this a parabola? Not at all. It is not a vertex. It's not a parabola. But why are you talking while I'm trying to teach?
I didn't say nothing. I didn't say nothing. I just looked away and you thought I was talking.
Someone was talking in that general direction.
He was a student.
He just was saying, yeah, you see, and I was trying to get a page.
The accusation.
So, is that a high point or a low point? High point. Looking over here at this wording,
Oh, domain.
what word would I use to describe a high point?
Range.
A high point, bro. Say it again. A maximum. I missed it, as in chill. Listen, if it's a high point, what are we going to call it? A maximum. Now, are there y values higher than this point? Maybe over here? Yes. So is this the absolute highest y point for the entire function?
No.
It's a range.
So we're not going to call it the absolute highest. We're going to call it a relative maximum. It is higher than the stuff around it. It is a relative maximum.
Yay.
But then down here, notice how it's decreasing, and then it hits this point. And what does it start to do after that?
Upgrade.
Starts to increase, right?
Upgrade.
So what are we going to call this point?
Upgrade.
A relative minimum. We're going to talk more about this and practice with it tomorrow. We're calling it max and min. Why is that door open? Corey, that's not wrong. Close the door. Close the door. Say it again. In general, I want to emphasize that that is the shape of a cubic function. When we see this set of curve, or this kind of curve, by the way, I do want to emphasize, how many curves are there right here?
Yeah.
2.
You see how many exponential curves?
How many curves are right here?
2.
1.
Oh, you talking about this one?
Yeah, I got it right.
How many functions are there?
2. 3.
3.
Right here?
1 function. 1 function.
One function. It is third degree. But remember, I asked the question, how many curves do I have?
1.
One, right? Because how many times do I pick up my marker as I draw it? I didn't pick it up once, did I? I was able to go all the way through, so it's one function, it's one curve. It's important to recognize that when we talk about a cubic, there may be multiple turns, when we talk about that later, but how many functions is it? One. It's one curve, one function, even though it has multiple turns. So here's what we're about to get into, and this is where I need you to have page 157 out, and I need everybody to have a calculator. So one person per group, go grab a calculator.
You got it. You got it, dude. I'm telling you. Your mama. Does somebody mind grabbing the water calculator?
Y'all play rock, paper, scissors?
Well, you're in the group you're supposed to be in, I bet someone's
Yeah, go get the guard. Guard can get right now. Guard can get
I do you right now.
I'm tired of learning.
I'm sorry you feel that way. What? You're about to what?
Learning, bro. Learning.
Learn? Let's learn. So guys, page 257, or 157 out of the textbook. I need it out.
Thank you, guys.
Can you what?
I'm trying to learn.
No, it's not about answering the question, it's about asking the question.
I had questions understanding.
Oh my gosh, and every time it's like, what's all that she knows?
It's got to be a quality question that pushes our understanding.
Yes, and they were like,
Hey, we're not talking about this life with class, we're talking about this algebra 2 class. Thank you. Okay, so, ladies and gentlemen, we are on this function right here. I need you to go ahead and type in that equation. One thing to keep in mind, so create a graph page, type in that equation. One thing to keep in mind when you type it in, you're going to have to put multiplication symbols in here. Okay, so I need you to go ahead, take up a calculator, type that equation in. Hey guys, do we have our calculators? Okay, each of you needs a calculator. I said one person per group go grab calculators, but each person needs a calculator.
Go fast. I can't help
You're not going to equation no more. Well, I'm about to type it in. There is the equation up on the board. Tyler, have you typed that equation in?
Bro, how do I type my equation in?
Type the equation in, bro.
Look, it just restarted. How am I supposed to type it in? It's restarted.
Remember I said you're going to have to put
What is it? Do it for
It's all.
It doesn't understand
One,
that.
Why are you cursing?
Pretty
sure it was.
Yes. You gotta make sure there's that multiplication symbol in there. If you don't, it'll tell you error.
I got straight up, straight
That does
line.
not look anything like that equation up here.
So,
Is that it right there?
I think first thing to say graph, and then
That might be it.
you
Hold
come
on,
out
wait,
there,
hold on.
look at you.
Let's get.
Did you put the multiplication symbol?
Oh my
between the
God.
X and the
Good
Z?
Boy.
That's it.
You gonna type it in, cuz.
Are y'all okay,
Brother Kenny,
Sir,
how do I do,
Dang, bro, I got
you gotta put that multiplication symbol in there. Yes, ma'am.
No.
It's the same from the textbook page.
Can I put the letter X? I use the letter X.
That's the variable X.
Yes, sure, bro.
Okay.
Mr. King.
So, ladies and gentlemen,
This is like a
I'm gonna hit enter.
cubic function.
Does it look like a cubic to you?
Whoa, whoa, whoa. Minnie, can I ever get that? Oh, wait, oh, my graph bigger.
That's because your graph has a different scale. Okay. X times 18 minus 2x times 12 minus 2x. Alright, so let's talk about this really quickly. Because some of y'all have a different scale because of something I was doing in first block. For a lot of us though, that's what it looks like.
Yes.
Like I'm putting it in.
Okay? So, what I need us to look at and think about is this. Why is that what I see?
Because, bro, you ain't got your scale. I mean, you got your.
So I need to change the scale. Guys, we should know based on this equation, what type of function do we have?
Linear quadratic multiplication.
Say again.
Oh, cubic.
Why do you say cubic?
We got three in the. We got three functions.
So like right here, this function, or that factor, how many zeros is that factor gonna have?
One.
It's gonna have one factor, or
Yes.
sorry, 1 0, right? So we got 1 0 right here. It's linear. How many zeros are we gonna have here?
One. What's it?
That's again linear.
And another
And
one.
right here.
One.
And so we have 3 zeros. This should look like a cubic function. Does this look anything like a cubic function?
No.
Yes, it does.
What little bit does?
Wait, what are we talking about? You talking about shorts?
I see 1, 2, 3 roots.
It does.
Not just points, roots, x-intercepts,
Yeah.
zeros, right? Okay, so what do we need to do if we want to see what this graph is actually supposed to look like? Okay, but here's the caution I'm going to give you. If you just zoom out, you are going to just zoom out both in the x and the y. I don't want to just zoom out in both the x and the y. I want to control what's happening. So, what's the button that lets me do cool crap?
Menu.
Alright, so please go to menu. And instead of just zoom, where am I going to go?
You're gonna go.
Go to 4, Windows/Zoom.
I'm going to go to Windows/Zoom, and I'm going to go specifically to the
Windows settings.
Windows settings.
What?
I'm going to go to Windows settings. Okay, so instead of Zoom, I'm going to go to Windows settings. And when you go to Windows settings, I just want us to think about this for a little bit. Do I need all of this x over here? Like, do I need to go to a minimum of -10?
No, bro.
No. But what might be a good x minimum?
Like 5
Positive 5?
or -5.
-5? Okay, I'm cool with minimum -5. What about an x maximum? See, I see a 9 right here, so maybe a little past that. Maybe a,
17, like 10, 15.
I'd say 12 to 15, somewhere in there. Let's go 12. You can probably go up to 15, that'd probably be fine.
I went up 200.
You didn't hit Windows settings and change the X like I told you. Windows settings. There you
What
go.
if you went 200?
So, let's think about our Y minimum. Now, we very clearly cannot see a lot here, can we?
No.
So I'm going to change my Y minimum and Y maximum by a lot. What do you think a good Y minimum, Y maximum to change it to
I
might
put
be?
200. 200.
So Y maximum or minimum?
Max.
So Y max of 200. All right. What about Y minimum then?
I put in a negative
Like
100.
negative 200.
Negative.
Okay. So let's try that for our Windows settings. Okay. Notice we don't know for sure yet. We're just guessing. And we're going to see what it looks like. So -5 to 12. negative 200 to 200. Okay, that's what we should see in our x min and x max, y min, y max. Okay, how does that look? Does that look pretty good?
Yeah.
Can I see my graph pretty well? Now, I will point out, do I really need all of this space for the y minimum? So maybe negative
I
100.
put negative 100.
Do I need more or less of my y max?
More.
A little bit more, so what do we want to try to make that y max? 250?
Nah, 300.
Let's try 250. If we need to make it bigger to 300, we can. Okay, so let's try that. Notice it's just a matter of playing around with it until it works. Tyler, you got this graph going?
Play around until it works.
You don't have to be a genius, you just got to be willing to try.
I feel you. So what is it? That's not it.
Alright, can I now see that curve, the most important details of that curve pretty easily?
Yes, sir.
Say again?
You got to leave.
So remember, we changed that, we said we didn't need all that lower bit of the y, so we made the y minimum negative 100.
Huh?
And then we made the y maximum 250.
Negative 5.
So remember menu.
I
The
mean,
button
negative
lets me do
5,
all my
negative
core
12.
graph with menu. And we're trying to change the window.
And when you go to the one with the zero,
So Windows slash zero, we're trying to change the window
it
settings.
don't, it gotta
Yep.
let
There
you
you
know.
go.
Let me see.
What it say?
So remember we
Bottom two.
Yeah, made that a little bigger. And you can leave that there, but we didn't need all that for the y min, so you can leave it there.
Y min is negative 100 and Y max is
250.
250.
Sir.
Why just having on my
Why me and what?
Y min is negative 1,000.
By the way, if you have two graphs on there, you can delete the old graph by clicking on it and delete.
250.
That's what I did in my first block. We're in a different spot with them. All right. So, ladies and gentlemen, I need eyes and ears on this, very clearly on this, because what I'm about to talk about is a recap from Algebra 1, but we are going to use it this unit as an introduction and heavily use it next unit. Heavily using it next unit, so I need us going ahead and making sure we understand this. What I'm about to ask about is based on the questions on page 157, parts C and D. So we're just focusing on C. C asked about the domain. I'm not going to tell you what the domain is here. I'm not asking you to tell me what the domain is. I'm just asking, what is domain? We've talked about this in Algebra 1. What do you remember about domain?
Domain and range.
Okay, so domain versus range, I'm with you on that.
And the
But-
X. And the X.
So be careful. So a lot of times people want to say x-intercepts.
What is the X?
So it's not the x-axis, you're 100%. Now remember, x-intercepts is just where the function intersects the x-axis.
That's value.
These are the only x-intercepts. And this is my x-axis, and that can be helpful, but that x-axis is an axis, right? It's a part of the graph of like creating that graph. But I'm talking about this function. So it's not x-intercepts, it's not just those 3 points, it's not the x-axis, it's the x values. I'm sorry, I didn't hear you. Okay, so it's the x values. By the way, what's another word for x values?
Root.
Now remember, roots are my zeros, my x-intercepts.
Input.
Close.
Input.
Inputs. It was something like that. Remember, x is my input for that function, right? So it is my inputs. And so when we say domain, we're not just saying some of the x values, we're not just saying part of the inputs, we're trying to find out what all of my x values are. And so when we say range, what do we mean by range?
Your Y value.
Your y values, which are also called outputs. And so, again, we want all of them. We need to describe, when I ask for domain and range, we need to describe all of my inputs and all of my outputs for that function. Now, there is a specific notation that we typically use in math that I'm going to talk about later. I'm going to, one, see if you already remember it and use it here, but I just need you, at your vertical surfaces, to come up with some kind of indication of what all the domain, or what all the x values, my domain, and all the y values, my range, are. Okay? So come up with some statement about what you think the domain and range is. That's it. So 3 minutes. We're going to come back together after you come up with your statement in 3 to 4 minutes.
Go say hey, Daddy.
I will think about what I'm gonna do with that Kit
He
Kat.
said you holding it.
I don't know. It's not my fault he dropped his Kit Kat.
Yes, it is. You got no way. The camera on?
Why is neither one of them? So one of them says it is a parabola, one of them says it's not. Okay, so what Vakari just said is it's crooked. So if it's crooked, does it have a line of symmetry?
No.
So if it doesn't have a line of symmetry, could it be a parabola?
No.
But it looks pretty symmetrical.
But look, again, you see right here where it starts to kick out a little bit, like that. That's not symmetrical. So is Lewis right? No. Now Heidi looked a little bit further out. And Heidi says, I notice that the graph curves back up, so it can't be a parabola. Hey guys, look at what Heidi did. Heidi zoomed out. Is this a parabola, or is it something else? Say it louder, Addison. We have a cubic here. Why do we know that this function is a cubic? So there's, I'm sorry, I thought I was teaching. Preston, ladies in the back, Jamie.
Oh no, Mr. Kid, I was answering your question.
Okay, you are not talking to Preston? My bad. Okay. So, how many zeros are there?
3.
3. If it's 3 zeros, what type of function is this going to be? A cubic function, right? So, we're going to go deeper into this cubic function, but I need us to pay attention to this. We are moving into these higher degree polynomials past quadratics. We don't have a parabola here. We have a cubic shape. We've seen this cubic showing up more and more often where it curves twice, right? Has 2 turns to it. When we come back from lunch, we're going to explore this cubic more heavily. Yes, you get to, is what I think you meant to say.
But I don't want to, Mr. Kennedy.
There's a lot of things I don't want to do,
I want to do not work anymore.
but Jamie, for real, my bad. She already walked out?
You always do that.
Okay.
Mr. Ken, I can't come to class. I hate my knee.
Right here. Those are the points we know that this function has to have. Because what are we doing when we dilate like this? When we multiply, what are we multiplying?
Everything.
The outputs. I need y'all to pay attention to this because a whole bunch of y'all in the demonstrated understanding looked at these y-intercepts. But here's the thing. I don't need to look at the y-intercepts. I can. But why do we know these points are going to be on f of x? Well, what's this y value down here? -3? And what's the y value right here? The y value.
I can't see.
The y value on the x-axis.
Not going.
0.
Wait, what? Oh, Y value.
Y value is on the x-axis, right?
Yeah.
So what is -3 times 0? So we know f of x has to have a 0 right here. What's this y value? 0. What's this y value?
0.
5.
You can look at your graph, by the way. 1, 2, 3.
They put no point there.
So 3 and times 0 is what? So we know, because we're multiplying the outputs, that we have to have those 2 points on f of x. How do I figure out what it looks like around those zeros?
Oh, the negative, positive, and the what you call it in your things. What you call it, that little thing right there?
Just in those domain regions or
no,
the range
yeah,
of the regions. So
Yeah.
like right here,
Positive, I mean negative,
that's negative, cool. Alright,
negative.
say that one more time. Most of us only looked at 2 negatives here. But how many factors do we have?
3.
How many positives or negatives should we be looking at?
3.
3. Why are you looking at me like that, Dewan?
Hold on. I ain't see no bird on what you
It's
call
in a
it.
different color.
No, remember
Oh,
how it's
oh,
the same factor right here?
I can't see that.
I know. Well, that's why I didn't assign it to. But red and brown are together because we have 2x minus 2's.
Yeah.
So, and that's why we want to think about the equation and the graph at the same time. How many factors does the equation have, Dewan?
How many factors?
3. And so how many factors do we need to pay attention to in the graph?
3.
So we have 3 negatives. And what's a negative times negative times negative?
Positive.
No, it's negative.
Negative.
Oh, you said when it's
You-
two,
uneven
when it's,
amount-
when it's
odd
even
amount.
amount of negatives, yeah.
It's
Yeah.
positive.
Yeah,
Because
yeah.
remember, it's every 2 that makes a positive, so it has to be an even amount to be positive.
True.
So that's negative. So we have all these negative values up to the 0.
Yes.
Alright? Now I gotta look in between. In between,
We got
these are
plus, negative, I mean positive
these are positive.
and positive. Wait, oh negative.
Those are 2 negatives.
I was
Remember, they're below the x-axis. So positive times negative times negative.
I can't do my drink.
No, not a can of Dr. Pepper. Did you open it all the way?
No, sir.
Can you go put it in my fridge?
It's gonna be a
Thank you, sir.
Give me a second. No, go ahead.
So, positive. So, notice this should make sense because does it bounce or does it go through?
It bounces.
Right here?
No, it go
No,
through.
it bounces, all the time.
Does it bounces later, but right here it went through because it's a single root. Over here we have a double root, so it should what? Bounce.
I was right.
And we have a positive times a positive times a positive, which is positive. So it bounces.
Hey.
Guys, all you have to do is pay attention to positives and negatives. You gotta pay attention to how many factors you have. If you wanna ask questions, I can see some of us questioning things. Jamie, what question do you have? Can't answer it if you don't ask that question.
We almost made it.
Bakari? We're gonna have that conversation a little bit later.
Dang, we ain't sit there.
What we doing right now?
What's up, Madison?
No.
I wasn't even talking to him. Where did you get the other negative on the last?
Conversation.
This one?
Yeah.
So remember, how many factors do we have?
We have 3.
We have 3, right? So there's one here, right?
That's above
That's positive.
it. That's
But remember, how many factors are right here?
that's.
Remember, I have 2x minus 2's, right? Both of those are negative. Remember how we had 3 negatives over here? Because negative, 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 positive, negative, negative. Does that make sense? That's why I did it in 2 different colors as well. I will say this, I'm not going to do that to you on an assessment, but because that is confusing when it's the same line, but that's what it is, right? It's the same line happening twice. Yes, Jamie.
Okay, so when we find the negative, like, so we go from the
Hold on a
outside to
second.
the
Tosh.
inside, back to outside.
Jamie's asking you a question, I need you to pay attention to this.
When we find the negative and stuff like that, we go from the outside to inside to outside.
What I would, yes, but what I would say more is, how do you read a book?
Left to right.
Left to right. So I'm going to start on the left side of my graph, and I'm going to go all the way up to 1 x-intercept, okay? I've got this region. Now I move to the next region, and then I move to the next region. The reason I say it like that is, if I have something that looks like this, right? I know that my dilated function is going to have this 0, it's going to have this 0, and it's going to have this 0.
Yes.
So I'm going to look at this region first, then this region, then this region, then this region. Notice how it went from left to right, just like I read a book. That's it. Ray, did you get your question answered?
Do they have a book that's right to left?
You looked at a question earlier. Did you have one that you figured out, or that you need to ask? No? You sure?
Miss Kim,
That mild section. Yes, DeWan.
do you think they have a book out there that's right to left?
Yes, there
Another
are.
question.
That's what. So how do we read? Is left to right, but Japanese read right to left. That's why if you ever look at a Japanese manga, it's the front of the book's actually on the right side, and the back of the book's on the left side.
That's an odd way to read.
They also read vertically and not horizontally.
Yeah.
What?
So they
How do you
read
read
this
up
way.
and down? Nah.
Well, they don't use letters like we do. They use characters. Sometimes.
Oh, you're right, you're right.
hold my hair all
No, it's not. You got that
that line right there.
right.
How do we get to ride back over to?
You did what you
Say that one more time.
How do we get the one with that line over to?
You talking about this one right here? So, hey guys, hey, bring it back. Tyler, this is going to help you. Pay attention to this instead of talking. Hey,
I didn't even say nothing to nobody. I turned around.
Tyler, if you use words, you are talking. I'm not gonna argue with you. You said words.
Alright, bro, you got it.
So, Taj, I didn't actually use the slope to get these 2 points.
Yes, Lord.
Remember, that's my y-intercept of -2. That 2 was my 0 or my x-intercept. Now, that matches the slope, because the slope is understood to be 1, up 1 to the right 1, up 1 to the right 1. But we just use the y-intercept and the x-intercept. And that's what I would oftentimes do for a line, is I would just figure out what's my x-intercept, my 0, and what's my y-intercept. It makes it way easier to graph a line. But your slope also will give you the same answer, okay? What other questions do we have? So Taj asked a good question, Jamie asked a good question,
I'll ask you a question first, too.
Dewan asked a question, I don't remember what it was, but sure.
I asked you about the Japanese books and stuff. Those are pretty great questions.
Did you meet?
Jamie and Taj, for y'all's question, you can get a piece of candy a little bit.
Wow.
There you go, right now.
Sure, Kenny, like, it's like,
That wasn't related to the math.
no,
Did you meet your
yes it was.
Christmas
You said somebody book, so I said somebody
No,
book.
I just had those in my
I
head.
think it's a piece of candy.
Did you put like X plus one?
Yeah, there are these factors. I graphed the factors. Okay, any other questions about this math?
When you went to the right.
No, it's Jamie's
Nah,
candy.
he could've took that risk.
Okay,
I got a question.
what, Taj? Not Taj,
They
Macari.
go to break, but I'll be breaking.
Macari, you missed the 10 minutes that went into this. We can talk later, but you missed the 10 minutes that go into this. Okay.
Dropping chips back.
Alright, so we're gonna do lessons 3 and 4 from the book today. That's not supposed to say DYU, sorry, I forgot to take that out. I changed things, but forgot to take out the DYU. We're about to get in.
Man, you didn't drop that. Oh God, I didn't drop it, DJ. That's what you get. That's
What?
Marking out of the game.
That's karma.
Come on.
He know he did that.
Hey, if you don't want to eat it, throw it in the trash. I'll think about it in a second. But I need us to get us going right here. Lessons 3 and 4 is what we're working on. We're going to do a quick reminder of the fundamental theorem of algebra, talk about multiplicity. But what we're going to focus on really first today is domain, range, and relative extrema. So we're going to talk about this. Actually, let's go ahead and talk about domain. No, I'll wait till we get to the lesson. At the end of today, we're going to talk about how we can get standard form from a factored form. So we have already foundationally talked about identifying zeros of a polynomial by using the zero product property. Literally did that with the bell ringer today. How can we determine if a polynomial in standard form and in factored form are equivalent? What can I do?
By solving the equations and seeing if they're true.
Maybe.
No, not bro. That was the best guess I could give.
But I don't want to guess. I want understanding.
But I don't understand.
How could I determine if these two functions are equivalent?
Verify. I mean,
Say it again. I could graph them. I heard you too.
man.
I could graph them. But Jamie and Addison, what am I going to look for when I graph them? The same what? So, hey, Deanna, go on. Ignore him. I don't know. Okay, so, do they need the same intercepts
No. Yes.
to be equivalent?
They need
Oh, yeah,
everything.
yeah.
They need
They need the
everything that
same-
the other one got.
They need everything that the other one's got, meaning that their graphs need to be
Equal.
Equivalent.
But they don't line up with each other, you know.
Equilateral.
Interesting.
Yeah, they be parallel, never mind.
What did you talk about? You just saw it.
so 2x squared minus x minus 6 and 2x plus 3 times x minus 2. Are those equivalent?
Yes, because they got the same, zeros and the same.
You're on the x-axis too, right?
So they got the same zeros, they got the same,
Vertex.
hey, come on, do I need to collect that until after class so we can focus? Okay.
The x-axis.
So it's not, so they have the same vertex, they have the same zeros, they have the same y-intercept, they have the same axis of symmetry. Guys, they have literally the same inputs mapping to the same outputs.
Yes.
That's the same language that I've used since the beginning. Every single point that is on this function is also for this function.
Did I not say that?
No, I just asked, are they equivalent?
What you talking
So
about?
how are you, like, how do you graph all this stuff?
The graph?
What do you mean?
I wonder if I'm supposed to be graph. Like what is the?
They're both graphs. I typed it into the
Like where are
calculator.
the points at? That's what I'm saying. Like how am I supposed to know where the points are?
Oh, okay.
You mark them.
So, here's what we need to remember is there's a point right here.
Yes.
Even though it's not shown as a point, that curve is a point. It's not just a point. How many points are on this curve? Not just a lot.
3. No, 2.
Not just 3, not just 2.
Oh, you said points. I thought
How
you said
many
intercepts.
points?
A lot of points. It's a whole bunch. More than you can count.
Yep, say it.
Infinity.
There's infinitely many. And when I put infinitely many points together, what is it going to make?
Infinite.
It's going to make a curve. Well, it's making this function, this curve. So, Amber, there are points on this graph. Anywhere that I can mark, that's a point.
Yes.
That's a point. Now, the only points that are really useful are the ones that are at the intersection of the coordinate grid.
Indeed.
So, these are the points that I would want to be using.
So what you graphing don't allow the F1 thing, so like you then graph 2 or x squared, or like negative 2.
What are you saying?
But, no. So, Amber, when I look at this right here, do you see this x, what's that x value right there? 1, 2. So the x value is 2. What's the y value? If you're not sure, let's type that 2 in right here. 2 times 2 squared minus 2 minus 6. What's 2 squared? 4. What's 2 times 4?
8.
8 minus 2 is?
6.
And 6 minus 6 is? That point is right here because the input of 2 gave me an output of 0. So it's not that I'm graphing 2x squared minus x and like these separately. I'm substituting a 2 in and getting a 0 out, so that's a point on the graph. If I substitute the point, or substitute an x of 1 in, I'm going to get an output of 1, 2, 3, 4, 5, or negative 5. So, 2 times 1 squared minus 1 minus 6. So, that's 2. What's 2 minus 1? What's 1 minus 6? That's why that point is on the curve. So, like, the graphs that we see result from inputs being substituted in and getting outputs out. The calculator does all those calculations like that to get these inputs and outputs. And we have both this factored form and this standard form graph, and we only see one function because they're the same. The same input of 2 has an output of 0 here and here. This input of 1 has an output of negative 5. 2 times 1 is 2. What's 2 plus 3?
5.
Okay.
Oh, you answered.
Yep. And what's fine? What's 1 minus 2? And what's 5 times negative 1? So notice how that input of 1 also gave me an output of negative 5. The same input mapped to the same output. So it's about substituting inputs in and getting outputs out. Now what we have learned, though, and I think, that ain't funny. What I think this will help some of us in thinking about is this. 2x plus 3 has a y-intercept of 3 and a slope of 2.
Yes.
Okay? Notice how that line, that's y equals 2x plus 3. Notice how that line goes through this 0 here? Right? X minus 2 has a y-intercept of negative 2,
For real.
a 0 of 2. You see how that goes through this point. we get our hoods off, please? Taj, J. Mike, Jaquel,
Jeez.
thank you guys.
Triple.
Cameron, Tyler.
Jeez. You're the kill streak.
Oh no, Mr. Kinney's asking us to follow the rules set for Hillcrest High School.
Bro, it's like, Jeez.
J. Mike, come on, man. You got a hat on too.
Man, folks, I always had it. I don't want
Can you please take your headphones out as well?
Well, you can't even pull your dreads,
Okay, so what I need y'all to notice is this. Looking at this 0, what kind of values does this factor have?
Negative.
This factor has?
Negative.
And what's a negative times a negative?
Positive.
Is that what we already saw in the graph?
Yes.
Then when I look in between, this factor has?
Positive.
And this has?
Negative.
What's a positive times a negative? Is that what we already saw in the graph?
Yes, positive.
Positive times a positive is?
Positive.
And is that what we saw in the graph?
Yes.
So remember, you don't have to have that level of accuracy, but I want us to recognize that we're multiplying those outputs, and I just have to know if they're positive or negative to get a sketch. But you have to have graphs of the factors to be able to make that happen. And so, Amber, what I will say is, like, at its core, what these functions are is you substitute an input in and get an output out. And you can take the time, and some teachers force students to take the time to type in multiple inputs like this. But I don't need you to do that and get the outputs and graph those points. I don't need you to do that. I just need you to recognize positives times negatives to get a general sketch of what that shape looks like. Huh?
Would that give me a CCC?
Well, but it's not doing the thing that I'm asking you to do, so not quite. If you want to do that on top of what I'm asking you to do, then you can. Okay, but I want us to be able to sketch what this function looks like from something like that.
My eye hurt.
Alright. So, once again, if they're equivalent, those graphs will be the same. They will, what we call, map to each other. Notice that's sketching polynomials when given the graphs of the factors, sketching polynomials when given the factored form of the polynomial, and then determining if a polynomial has positive, negative, or 0 based on the graphs of the factors. That we've done this entire proficiency scale at this point. What we're working on today is looking at domain, range, and intercepts from a polynomial function, and that's going to be based off of graphs. And we're going to be working on determining the standard form of a polynomial as well. So that's the focus. We will do some of these other things a little embedded within that. So do not forget, let's recap this. Preston,
Wrong. Come on, Preston, let's go.
how many zeros will this function have?
3.
Why do you think it's 3?
Because there's 3 x's.
Okay. How many zeros do you think this one would have, Preston?
2.
2?
Yep.
So because of the number of x's?
Yep.
Okay. Anybody want to push back on how many zeros these two functions will have? The one.
It will have 3 because it's the degree of power.
Oh yeah,
Third power.
Oh, so it's the highest power, the degree? So don't forget that, right? It's a third degree, so it has how many zeros?
3.
3.
Preston.
So how many zeros will this function have?
2.
2? Hey guys, I need y'all to all look at this and understand this foundational piece right here.
Yes.
How many zeros will this function have?
I can't see your head.
2?
No, it'd be 3 because it's dilated as well.
So notice it's dilated. Is this in standard form? The whole thing? No. When I look at this, we need to recognize how many zeros would this function have. This function has 2 zeros, and then we are dilating and creating. So remember, when we dilate, when we multiply, it's going to create more zeros.
Yes.
How many more am I making?
1.
So how many total zeros?
3.
So what degree?
3.
I need you to pay attention to this difference between standard form and factored form. In factored form, you have to think about how many zeros each factor has, because if I multiply by 0, what do I get? If we multiply by 0, we get a 0.
Yes.
So, we gotta pay attention to that difference.
Is that 0
Now,
bad?
Jaquel, can you hit the lights for me? Yes, sir. Say again. Say that one more time. Sorry, I can't hear you because the medium, hold off on that. There's anybody that didn't choose that one yet. Okay. Alright, I know, but there's something I want to talk about with that one, Taj, before you do that medium. Alright, here I want us to look at activity 3.1. So, Lewis, Ahmed, and Heidi use graphing technology to analyze a volume function sketch. We're going to look at this actual volume function in a second. Okay, right here. Now, Lewis made the claim that the graph increases then decreases, so this function is a parabola. Ahmed said the graph lacks a line of symmetry, so it can't be a parabola. What do y'all think about Lewis versus Ahmed? Which one is right?